Hello, geometry students. For Mr. Fry, this is February 12th, and I want to take a look at all of the odd problems for you on this Unit 7 Homework 2 parallelograms. I went ahead and wrote down all of the data that you would need to use for answering number 1. And so I have for MN 31, KN 45, and then these angles as listed here due to the information that we have and the definition of a parallelogram with opposite sides being equal, opposite angles being equal, and corresponding angles equaling 180, all that information that we've received over the past couple days. For number 3, you could see that I put all this data in that was listed in the directions for number 3. And you may want to pause this and jot down some of these numbers. And then using the information that we have, we were able to find these side lengths and these angle measures. And in the angle measures, you could see what I did in order to figure out what those final angle measures were. For number 5, I have here where AC is going to be equal to double what EC is, because AC is the entire length of that diagonal and EC is half of it. So I'm going to double EC to equal AC to find out what X equals. And that's how I did that problem. For number 7, these two angles are going to equal, so I'm going to solve for X. When I solve for X, I'm going to plug it back in. I used this one, seemed to be the easiest one, and I got 43 for this angle. Now, V is going to be 180 minus that 43, okay? Because remember, corresponding angles are going to be supplementary. So if I subtract 43 from 180, I get 137. So that's how angle V is 137. For number 9, we have VST and VUT, and we have them equaling each other, and I solve for X. Then I went and plugged that back in for VST to figure out what that was, and then I knew that this angle SVU would be 180 minus that. I know that WVU is 20 degrees, so I'm going to take whatever SVU is minus 20 to get what SVW or SVT would be, and that would be 17. That would be what was left over. And for number 11, we are using the slope formula. And so I went ahead and labeled all these x1, x1, y1, x2, y2, x1, y1, x2, y2, right? Okay, so I took these two first ones, these first two sides, and I solved for slope, and notice that they had the same slope. Well, these two and these two had the same slope. And then I went ahead and mixed, so I had these ones go with these two. Now I had these ones go with these two, and these ones go with these twos. So I got the same slope there too. So that tells me that each of the sides are, having the slopes. So it's probably a parallelogram if they're going to be having the same slope. That means they're going to be parallel to each other. So both sets are parallel to each other. So yeah, it's going to be a parallelogram. For these, you'll need a distance formula, 10, and you'll need a distance formula for number 12. Just Google the distance formula and you'll be able to, find that, or look back in your notes and you'll be able to find that real quick and easy and use the distance formula to solve those. And try those on your own. If you make a mistake, no big worry. That's, you learn from it, and that's how we grow. Good luck.